These are the minimizer proving grounds. This is where perfectly good fenders come to be dropped, hit, burned, froze, pelted, crushed, and annihilated by engineers using any and all means necessary to prove that a minimizer fender outperforms and outlasts all other poly and metal fenders. Oh, in case you're wondering, the tests they conduct at the minimizer proving grounds are not real world. They're a whole lot worse. This is the primary test subject for punishment. Meet the minimizer fender. Its build is tough, rugged, and ready for whatever life and the road throws at it. Let's see if minimizer fender is everything it claims to be. It's a cold world, and it's about to get a whole lot colder. Welcome to the Arctic Cold Test. Proving ground engineers will subject off-the-shelf fenders to liquid nitrogen, so we can see how well they resist shattering in cold temperatures. Make that super cold. If you didn't already know, liquid nitrogen is about 320 degrees below freezing. In fact, it's so cold that you can turn a near mushy banana into a rock-hard hammer. Our cold combatants for the Arctic Cold Test will be the minimizer fender against a standard poly fender. Now, the only question: who can withstand the chill and who will shatter under the pressure? Getting the deep freeze treatment first is the poly fender. The proving ground engineers add a bit of liquid nitrogen, and in no time, the fender temperature dips way down below freezing. And here comes the sledgehammer. Oh, ouch. Time for the science. The nitrogen is about 320 degrees below freezing. Thanks to the liquid nitrogen, the proving ground engineers were able to chill the fender to roughly 21 degrees below zero. And let's not forget the sledgehammer. It's a 16-pound sledgehammer, traveling on an arc that's about 9 feet long, at an average speed somewhere near 25 miles per hour. This creates a load of force all directed at a very cold surface. And since the poly fender was frozen, it didn't flex. It just shattered like glass. So what happens when we chill the minimizer fender? It's time to find out. But the odds don't look good. And the minimizer fender flexes without fracturing, despite being frozen with liquid nitrogen. Using the slow motion camera, you can see how the minimizer's superior hybrid poly absorbs the blow without being damaged. The bottom line, when it comes to the Arctic Cold Test, minimizer fenders shatter the competition. It's time for something the engineers at the minimizer proving grounds refer to as disaster from above. In this test, disaster is represented by a 100-pound anvil hanging 16 feet in the air. At that height and weight, we'll be delivering a whole lot of pure damage-inflicting force. Impact is sure to be ugly. And who, you ask, are victims for this test? Well, that's easy enough to guess. Test subject number 1, the minimizer fender, and test subject number 2, the classic metal fender. Let's see who will collapse under the pressure and who can take the impact. The test begins by placing a minimizer fender into the drop zone. Now, let's break down the science of just what happened. When hoisted up, it's 16 feet above the target. As it drops, it covers those 16 feet in about 1/4 of a second. That means it's traveling at an average speed of 20 miles an hour. Do a little math, and you end up with a punishing 21,693 newtons. That equates to 4,876 pounds of force delivered at impact. Now let's see what all those numbers mean when we apply them to a metal fender. Same test, same anvil, same pounds of force, but a very, and I do mean very, different outcome. When it comes to the death from above test, the clear winner is minimizer fenders. Welcome to a little test we like to call Hardball. This is a pitching machine with the uncanny ability to hurl projectiles like a baseball or, say, a pool ball at speeds approaching 100 miles an hour. And at the other side of the proving grounds is where the unlucky catcher of our comic quick pool ball will be positioned. Sure, we can tell you this test is to simulate how well a fender can stand up to flying road debris and potential puncture damage. I mean, we really could tell you that, but we won't. Really, this test just sounded like fun. Leading off, in front of the proving grounds firing squad is the minimizer fender, with a stainless fender warming up in the on-deck circle. Let's see if either one of them is ready for the Hall of Fame. The hardball test begins by placing the minimizer fender in the test zone. So let's look inside the numbers. The pool ball weighs 6 ounces. The pitching machine, well, it's projecting the pool ball at about 95 miles per hour, and the distance traveled from machine to impact is 28 feet. In other words, it's packing a powerful punch. But how well can the minimizer fender stand up to multiple punches? According to our proving grounds engineers, there's only one way to find out. The result is the same. Plenty of impact, not a single sign of damage. Now at the plate, an oh so shiny fender. Yep, that one left a mark. And the more pool balls, the more marks. Like that one, and that one, and that one, and well, you get the idea. Our once pretty fender looks thoroughly bludgeoned by a hailstorm from hell. In the hardball showdown, the championship pennant goes to minimizer fenders. It's time for the proving ground engineers to gear up for a test they like to call pancakes. Basically, we're making pancakes, but instead of the buttermilk batter, we're using fenders, and rather than a skillet, we had our friend Randy bring his tank. Meet Tootsie, a British military GKN Sankey FV432 to be exact. And no, we're not putting any fenders on the tank. We're putting the tank on the fenders. In this test, Randy's tank will run over each fender to see how well it responds to being crushed. Then, we'll see if the fender can bounce back to its original form and function. Oh, in case you might be wondering, the FV432 weighs just a smidgen over 15 tons. And who is going to war against the tank? In the red corner, you have the minimizer fender. And in the black corner, a fiberglass fender. Let's see which of these combatants, if any, can take the weight. First up in the test zone is the minimizer fender. As you can see, Tootsie is no lightweight, and it looks like she did a whole lot of damage. But look here, the minimizer fender is easily popped back into shape and ready for more. So let's break down what happened. The slow motion footage shows every crushing millisecond of Tootsie's 30,000 pounds as she completely deforms the minimizer fender into a pancake. Now, let's find out how well a fiberglass fender will fare against Tootsie in the same test. It's not pretty. In fact, it's pretty much total fender annihilation. It's an easy call to make. In the battle of tank cakes, it's the minimizer fender 1, fiberglass fenders 0.